Hi, my name is Casey Walters. I'm in Miss Benzies fall quantitative literacy class, and I am going to be um, showing you my Module 2 Excel report on probabilities. In number one, there was a survey conducted in 2008. They found that 500 men and 500 women were surveyed, and they were asked to provide their opinions in a poll. And we found there were about 50% of the people who said no. Then we learned that if you were to look at just the women, the probability that the women had said no was 43%. And if you chose a man, the probability that he said yes or not sure was 43%. This is an example of empirical probabilities because they are actually calculated from a survey or an experiment. We can use empirical probability if data was collected from a good survey that was unbiased and random samples were taken. Then the probability found from the survey can be used to project outcomes for what you would think could happen on a larger projection or within a larger population. And what you'll see here in my Excel report is I have a table here, and I have defined the variables. And then in the first one, it is the fractions. And then I have reduced fractions over here. And of course, I put in the formulas for each one. So Excel calculated it, which is really handy and quick tool to use. And then in the next one, we were asked to put it in decimal to the thousandths and then percent to the tenths. And over here, I actually have the responses from all parties involved in the survey, and then separated with men, women, and then all together. And then that is how I was able to get my outcomes. Now, number two, in this problem, we were asked to find the probability of rolling 2 die at one time and getting the list of results. I found that the probability of getting the sum of an even number would be 18 and 36, or 1 and 2, or as a decimal, it'd be 0.5 or 50%. Next, I found that the probability of rolling the product of a prime number would be 5 and 36, or 1 and 7. Or it would also be 13.9 or 14%. The next part asks us what is the probability of the sum of being a multiple of 3, and that would be 12 and 36, or 1 and 3, or 0.333, or 33.33%. Finally, we were asked what the probability of getting a product of 12 would be, and that is 7 and 36, or 1 and 5, or as a decimal, that'd be 0.194, or rounded to 19%. And these tables right here are the defined variables, or actually what we were looking for. And then this is where I plugged in the numbers, and then I was able to get the probabilities, and I used the formulas as well as all of the formatting capabilities in Excel to quickly get this taken care of. And over here, I've also got up my tables that we used in our last section or module, and so that you can also do it and just find it real easy. And I've color coded each table to show how many there actually are, so that you can count it up visually as well. And moving right along, number three, in this problem, we were asked to create a table using the odds to calculate probabilities for each numerical outcome from the player's perspective. And I found the expected outcome would be a loss of $1.93 for the buyers and a gain of $1.93 for the sellers. The seller's expected outcome for selling 5 million tickets would be 9,700,000. I also had done some research for the state of Arkansas's lottery commission, and it turns out the state's revenue for scratch offs for scratch-off tickets for the month of July 2013 soared to $13.4 million from $29.5 million a year ago. So definitely an increase. Looks like the state is making all the money when it comes to lottery tickets. But one good thing about Arkansas also that I don't have listed on here is that Arkansas is one of the few states that has an Arkansas lottery scholarship, and it really does benefit a whole lot of people. So anyway, the odds are not in your favor, but when it comes to scholarships, it may just be that you or your family member does have it in their favor. Now I have tables over here surrounding this that where I put in the first table row is the tickets and amounts spent on the tickets, and then the outcomes in the next, and then probability fractions, probability decimal, percentage, and expected outcome. Now, you see the answers here in here, but the great thing about Excel is that I was able to actually put the variables in, and then the formula, and Excel actually produced all of these numbers for me, which is great.
Why? Why should we use manipulatives and pictures? It can help students take an abstract idea and make it more concrete.
And
even though a picture is
over here to the right above the summary, I have the actual that's where I was able to figure the buyer's expected outcome and the seller's expected outcome. And that's where I have that charted out. So next I've got a lot of colors and designs here, but in this problem we were asked to find the odds in favor and odds against the event with probability. And I have the formula written right here, so you don't have to just hover over this in order to get it. And we were asked to draw a diagram for both odds in favor and odds against. We were also asked to label our results as fractions, reduced fractions, decimals to the nearest thousandths, and percent to the nearest tenth. The odds in favor were 9 and 4, or 2.250, or 225.0%, and the odds against were 4 and 9, or 0.444, or 44.4%. And I found all of this by plugging in the information provided into a table. And then I put the formulas in here, and then Excel's handy tools actually got me each fraction, reduced fraction, decimal to the nearest thousand, and percent to the nearest tenth. Using a calculator, this would have taken a long time, but really gotten used to, and to where I like Excel because it helps and really reduces your time spent on these problems. So over here I have here's our table, and then odds in favor and odds against. I have actually utilized the graphing option for our tabled results, and here I have a bar graph that also shows the answers. And then I also went a little step further, and I made a just a imagery that is real similar, since I've really gotten to like Venn diagrams. So on to number 5, finding probability from a 2008 survey of the total number of military members per branch of service. And what I've done here is I actually made tables with all the data that we were going to be using, and then I also put in the formulas in order to get the fractions, and in order to separate all of the information and get the information that they asked of us. So, and then from these tabled answers, I was able to use Excel's handy dandy tools and make some graphs over here that made it a lot easier to understand. So in question number 5, we were asked to create a spreadsheet by following the data presented to us in our exam, which is right here. And we were also asked to find the probability that an individual was a woman who was in the Air Force, Marines, and Coast Guard. I found that there were 81,390 women in these 3 branches of service combined out of 564,235 total soldiers. Next, we were asked to write the reduced fraction decimal to thousands place and percent to the tenths. And like I said, this would be frustrating and take a really long time to find all of these. But with use of Excel and knowing how to use it and put in the formulas and get it to get our fractions and decimals for us, these charts are really easy to do and calculate. And then, like I said, all you have to do is press button, highlight the table, and then it'll graph it for you. So it's pretty awesome. Anyway, I've also created, the graph, like I said. And additionally, I was asked to find the number of men within the Army, which is 465,843 of 539,170, or 108 to 125, or 0.864, or 86.4%. Next, we were asked to find the number of women given they were not a Marine, and I found that would be 15.5%, or as a decimal, it would be 0.155, or 92 out of 593. So it's pretty interesting. And then number 6, our final question here, it was on binomial distribution questions and classmates' claims. And what I did was I had I put all of the data into tables and made it where it was real easy and clear to see. And also I put in the formulas in order to get the distributions and calculated in percentages and everything else too. So you'll see I did it very strategically, and it's very easy to see, and you can always hover over it and it'll show you the formula up here. But I also wrote them right here so that you would see them and hopefully be able to figure it out if this is your first time with this. Who knows? Ms. Benzie, you may decide to use this as a help video instead of having to record one next semester. I hope I've helped. It helped me for sure. Anyway, and basically in this last question, we were dealing with, like I said, the binomial distribution formulas in order to determine whether or not we would believe a classmate who claims to have scored an 8 out of 10 on a quiz by choosing random answers. I found the probability of this happening is 0.038624%. I would not believe this classmate's claim based on my calculations. The chances of this happening would be extremely low, very small chances. And right here, I have copied and pasted the path for my assignment. So it's easy to see that this is in fact my work. I hope that I have helped to demonstrate and explain how to get probabilities and binomial distributions and formulas, as well as giving you an opportunity to see what Excel can really help you do and how fun it can be. Hope you have a great day. Thank you. Goodbye.
And add 0, it will be that whole number. The last property is a closure property, and it states that any whole number